Unit 5B Study Guide Key. Okay, for this first problem, we need to expand the logs. So look back at your log properties if you need to in your notes. But notice on the inside here with the 5 and the x, we have multiplication going on between 5 and x. So we're going to break the multiplication up with addition. So log base 2 of 5 plus log base 2 of x. I'm done now because I just have a 5 and an x inside the log. There's no more multiplication, division, exponents, anything like that going on. Number 2, same idea to start with. I have 7 times x plus 4, so I'm going to do log of 7 plus log of x to the 4th. Now, I do have an exponent here, so I need to take care of that. It's going to come out front, so keep log 7 plus 4 log of x, and now we're done. With my last one, I have division going on, so I need to start by breaking up my division with subtraction. So log base 6 of the top, which is 2x, minus log base 6 of the bottom, which is y. Now, this term, log base 6 of y, is done. Y is just by itself, no multiplication, division, or exponents going on. But my 2x, I still have multiplication in there. So I'm going to break that up as log base 6 of 2 plus log base 6 of x. And I still have minus log base 6 of y. Okay, now we're going to condense the logs. So since I have a subtraction sign going on with two logs, I know I can combine the insides using division. So I'm going to have log base 7 of 3 divided by 5. This first number always goes on the top. The second number always goes on the bottom. Same thing with the next problem. I have a minus sign in the middle, so I'm going to make this log of 10 over 5. If you can simplify the inside, you need to make sure to do that. This just becomes log of 2, because 10 divided by 5 is 2. Okay, with number 6, I have this 3 out front and this 9 out front. I need to start with these. These actually become exponents, so we need to bring them back up. So we get ln of x to the 3rd power plus ln of y to the 9th power. Now I have addition going on in the middle. I need to use multiplication now with my x to the 3rd and y to the 9th. So I have ln x to the 3rd, y to the 9th. Okay, we're going to use change of base to evaluate these logs. So with change of base, I always look at which of the numbers, 3 or 5, is currently higher. So literally written higher than the other one. That'd be the 3. So I'm going to put log of 3 on the top, because 3 was higher, and log of 5 on the bottom, because my 5 was lower. If you enter this in your calculator, you get 0.683. Always round to 3 decimal places. Okay, next one, 11 is higher than 2, so log of 11 over log of 2. Put it in your calculator, and you get 3.460. Last one, 10 is higher than 6, so it's going to be log of 10 divided by log of 6. We get 1.285. Please make sure that you know how to enter these in your calculator. These will be easy problems on the test, assuming that you know how to enter these in your calculator. Okay, so now we have this word problem about intensity, and we did this in your notes, so if you need to go back and look at that, you can. The problem says, for a sound with intensity I, the loudness, L of I, of the sound is given by this function right here, where I sub 0 is the intensity of a barely audible sound, about 10 to the negative 12. So we're going to plug this in for I sub 0. Find the decibel level of the sound made by each object. So the first one is a barking dog. We have I is equal to 10 to the negative 4. This W over m squared is just a unit. So we're going to take our equation. We're going to plug in 10 to the negative 4 for I, because that's what the problem says. And for I sub 0, we're going to plug in 10 to the negative 12, because that's what we got out of the problem that we read. Okay, if you enter this whole thing in your calculator, you're going to get 80 decibels. Next, we have an ambulance. Same idea. You're going to plug 10 to the negative 12 in for I sub naught and 10 to the 0 in for I. When you plug this in your calculator, you get 120 decibels. Okay, again, this is a problem just like in your notes. A chemist defines the acidity or alkalinity of a substance according to the formula pH equals negative log of H plus, where H plus is the hydrogen ion concentration measured in moles per liter. Solutions with a pH value less than 7 are acidic, solutions with a pH value greater than 7 are basic, and solutions with a pH value of 7 are pure, or such as pure water, are neutral. So we want to find the pH of a solution with a hydronium ion concentration of 5.3 times 10 to the negative 7. So all we're going to do is take this number and plug it in for H. So our formula is pH equals negative log of 5.3 times 10 to the negative 7. So once you enter that in your calculator, you're going to get 6.3. Make sure that you don't leave your answer here, because the question is asking for the pH. And I want you to tell me whether it's acidic or basic or a neutral. And this one is going to be acidic because it's less than 7. Okay, so now we're going to solve exponential equations. So with this first problem, notice we have common bases, both base 6. We can just set our exponents equal and solve now. So I'm going to subtract x over and subtract 3 over. I get negative 10 equals x. For number 13, I again have common bases, so I can just set my exponents equal. Subtract over the 3, divide by 2, and we get x equals 2. With this last one, we don't have common bases. I have a 3 and a 9, so I'm going to want to rewrite 9 using base 3. So the way that we can rewrite 9 is just 3 squared. So I'm just going to replace 9 with 3 squared. And now I have common bases going on. Right here with my 2 and my x minus 3, I'm going to use multiplication. So setting equal my exponents, I have x plus 1 equals 2 times x minus 3. Make sure to distribute. Subtract over my x, add over my 6. I get x equals 7. Okay, for this next one, I cannot rewrite 2 or 5 to have a common base. I can't rewrite 5 as 2 to some power. So I'm just going to change it to log form. So that's going to be log base 2 of 5 equals x. So now I can use my change of base formula to find x. If you plug that in your calculator, you get x equals 2.322. Same with this next one. I cannot rewrite 35 as 8 to a power, so I'm going to rewrite it as log base 8 of 35 equals x. Using change of base, I have log of 35 over log of 8. Put that in your calculator, and you get 1.710. Okay, with 17, we can rewrite these using common bases, but my base isn't going to be 16 or 1/4. My base is actually going to be 4 here. I know that I can rewrite 16 as 4 squared, and I can rewrite 1/4 as 4 to the negative 1. This is definitely something you're going to need to know for your test, so make sure that you know how to rewrite something from a fraction to a whole number with an exponent. Okay, so 16 is going to become 4 squared. I just replaced 16 with 4 squared. And 1/4 is going to become 4 to the negative 1. So I have common bases. I can write out my exponents now. It's 2 times 3x minus 2, and negative 1 times 5 minus x. Distribute. And now I can get terms on the same side. So I'm going to subtract my x over and add my 4 over. Divide both sides by 5, and we get x equals negative 1 over 5. Okay, so now we have some log equations. Just like with the exponential equations, if my bases were the same, like number 12 where I had base 6 and base 6, if I have log on the same side, I can just set the insides of the log equal, just like I set my exponents equal. So we've got 4x plus 1 equals 25. Subtract over the 1, and then divide by x. Or, I'm sorry, by 4. We get x equals 6. Okay, with this next one, I have a log just on the left side, so I'm going to change this to exponential form. So I'm going to say 6 squared equals 5x plus 4. Six squared is just 36. And now I just have a linear equation to solve. Subtract over the 4. And then divide both sides by 5. Okay, this number 20 is just like 18. We have a log on both sides, so I'm just going to set the insides of the log equal. Subtract over my 4x. And divide by 2, we get x equals 1.